Hello, my name is Anna Garrison. I'm an undergraduate researcher in the Josty lab. So today I'm talking to you about my research studying these super cool macromolecules called cycloparaphenylenes, also known as CPPs, and their potential to serve as bioorthogonal imaging reagents. So to start off, I want to introduce to you CPPs as they have really unique photophysical properties, so including a common absorption and a redshift emission as you decrease the size of the hoop. So CPPs can also be synthesized with an alkyne in it. So these alkyne-containing CPPs we refer to as n+1 CPPs. So n is the number of benzene rings and 1 is the number of alkynes in it. And this was first synthesized by Dr. Tobias Schaub, a former JOST member. And so what he found in his research is even with these alkynes in the CPPs, we still see the same general photophysical properties, to these super cool fluorescent properties. All right, and so current research is being done by a graduate researcher in the Josty lab, Julia Fair. And so she's studying the rates at which these CPPs react, these n+1 CPPs. And so she's derived second order rate constants for different sizes of n+1 CPPs, and also the rate constants of a couple of different modulations that can be done on these CPPs. And so this meta-linked 9+1 CPP is really interesting because it, via this meta-linkage, introduces a lot of local ring strain. And so, as you can see, it really increases the reactivity of this molecule. All right, so I've talked about, a bioorthogonal imaging reagent. So in order to image a biomolecule with like a fluorescent CPP, we have to form a linkage between this CPP and a biomolecule. And so a typical means of chemical ligation is the reaction between an azide and an alkyne through a 3+2 cycloaddition to form this triazyl. And so generally this ligation reaction occurs via a copper catalyzed, but copper is very toxic. And so this is why we are using the SPAC reaction, the strain promoted azide alkyne cycloaddition, which was first done in the Bertozzi group. And so instead of using copper, it introduces a strain cyclooctane where the ring strain destabilizes the alkyne, and this destabilization, increases the reaction driving force and the desire for that cycloalkyne to relieve its ring strain and react. Alrighty, so a lot of my research includes, synthesizing these two CPPs, the 9+1 and the meta 9+1. And so the reason I chose, the meta 9+1 and the regular 9+1 is because they have varying reactivities, as you can tell from Julia's work. And so it'll be interesting to see how varying reactivities translate to their efficiency to react in the SPAC reaction and also, just being able to label a biomolecule. So in order to investigate the capability of something such as a probe to be bioorthogonal, we consider the stability of this probe in a solution of biological nucleophile. And so we incubated our 9+1 CPP in a solution of GSH, so this is a biological nucleophile in solution. And so we analyzed these two in solution via NMR over a time period of 24 hours. And as you can see, unfortunately, a reaction did occur, but after further analysis, we determined that the CPP reacted with the thiol group in GSH. And it actually occurred via a different click reaction, not the SPAC reaction, but the thiol-ine reaction. All right, so the next stability experiment we looked at is just the ability for the 9+1 CPP to survive at physiological temperature. So at 37, roughly 37 degrees Celsius. And so the NMR showed, pretty minimal degradation over the course of 7 days. And so this was a pretty promising result. So key findings for my preliminary results are that, CPPs will in fact survive at cellular temperature. And they can also react in other click reactions that we hadn't necessarily considered, such as that thiol-ine click reaction. And so this suggests its potential in creating biological materials that could be used for potentially medical purposes. Future directions is to actually perform the SPAC reaction I mentioned before and to label a biomolecule with the CPP. And lastly, I want to acknowledge my PI, Ramesh Josty, for allowing me to do this incredible research in his lab, and Julia Fair for her unending mentorship in teaching me everything I know about this research.